In this video, I'm going to take a look at average acceleration and look at something that's slowing down, or what we call a deceleration rate. Physicists still use the word acceleration, it's just that we get negative accelerations. So for this example, I'm going to use a spaceship that's initially traveling at 1,000 meters per second. So the initial velocity, V initial, is 1,000 meters per second, and because it enters the atmosphere at some point of this planet, it's going to slow down to final velocity of 500 meters per second, cut in half. And the time frame that's going to take, the initial time, again this is when we start our stopwatch when this event occurs, the initial time is going to be 0 meters per 0 seconds, because that's when we start our stopwatch, 0 seconds. And the final time, or the time it takes for this, is going to be 100 seconds. So we're going to find the average velocity, a bar, and a bar again is equal to, so I want to see on the homework, the change in velocity with the change in time, which breaks down to specifically the final velocity minus the initial velocity over the final time minus the initial time. So for the variables, average acceleration, we don't know, per box, and the initial velocity is 1,000 meters per second, and it's a vector, so it's really like an arrow that points to the right here, and this one is a vector that's half the magnitude or half the value, so it's half as long. That's what that means. Initial time, we'll say 0. Again, that's when we start the stopwatch for this event. The final velocity is 500 meters per second, and the time, the final time, which is the time elapsed, is 100 seconds. So in this example, if you look at the order of the variables, it's always, remember, it's final minus initial. We're going to have average velocity is, let's see, the final is 500 minus the initial of 1,000, so you see we're going to get a negative value on top there, divided by the final time, which is 100, minus 0. And so we get minus 500 over 100, or negative 5 meters per second squared. So the negative sign here, and if you look at the example, we're slowing down. So the negative sign means it's a vector, but it points in the negative direction, like this. And this acceleration, because it points or opposes the velocity, it wants to slow this velocity down, so it opposes the motion. So you can see it's a longer vector here, and it's shorter here. And that's the job of this acceleration vector, because it points in the negative direction. If I want to say, last example we said this was to the east over there, like this. So if I put east there, you could say the negative east direction, or a non-physicist would say just toward the west. But that's how the negative sign comes into play. So negative 5 meters per second squared, and we'll say east. But we know that negative east is really west. And I'll box this up there. So this is an example of a deceleration type problem. List equation, list variables, and solve.